I'm your host, Dr. D. Welcome to Math in the House. Today, we're doing Math Analysis, Chapter 8, Section 5, Parametric Equations and Graphs. I'm your host, Dr. D. Now, parametric equations are equations where x is a function of t and y is some other function of t. T is called the parameter, and most of the time that parameter is time. So, in a rectangular function, you have x's and y's, and the points have no sequence. It's basically you have a bunch of points, like points that make a straight line. Well, they don't start anywhere or go anywhere, they're just there. But in parametric functions, there is a start and a finish and a progression from t equals 0 to t equals infinity, or t equals negative infinity to t equals infinity, or t equals some value to t equals some other value. So it's like a stopwatch starts and it finishes, and there are points that are created in between that start and finish point. So rectangular function, no particular direction, but parametric functions have direction. Let's check that out. All right, so we have x is a function of t, and y is a different function of t. And then we say, well, what's t? It goes from -3 to 3, including -3 and 3. Okay, so what do? As usual, we plot points. Okay, so we start with x equals t squared minus 1. So I'm going to put in t equals -3, -2, -1, 0, 1, 2, and 3, because that's what it says t is. So when t is -3, I have 9 minus 1, which is 8. t is -2. 4 minus 1 is 3. t is -1. 1 minus 1 is 0. t is 0. 0 minus 1 is -1. t is 1, 2, and 3, same thing as -1, -2, -3. So we have our x's as a function of t. Then I do the same thing with y. When t is -3, y is -6 plus 3 is -3. When t is -2, I have -4 plus 3 is -1. When t is -1, I have -2 plus 3 is 1. When t is 0, I have 0 plus 3 is 3. t is 1, I have 2 plus 3 is 5. t is 2, y is 7. t is 3, y is 9. So now, notice what I have then. At any given t value, I have an x and a y value. So now I can graph those xy values. So my first point is 8, -3. So notice I plot the point 8, -3, and I mark it at t equals -3. Now the next point is 3, -1. So basically the progress has gone from t equals -3 to t equals -2. And then next one, 0, 1, that's t equals -1. The point 1, 3, or -1, 3, I mean, you're at t equals 0. So t going from -3 to 0 and then back to +3. So this looks like a parabola, but normally when we draw a parabola in x and y coordinates in a rectangular equation, then I have an arrow going to the right, and, well, I'd graph it like this. So it's going like that. So basically there is no order, it's just going forever up to the right and forever down to the right. Well, here we have a start and a finish and an order, a progression. Okay. Now, let's try another one. X equals 3 cosine t and y equals 5 sine t. Well, this time, what t's are we going to choose? We're going to choose t values that make convenient sine and cosines. So I'm picking from 0 to pi, and then I'm going to continue on from pi to 2 pi. Okay, so when t equals 0, x is 3 cosine of 0, which is 3 times 1 is 3. Y is 5 sine of 0, which is 5 times 0 is 0. I put in pi over 6, and I get cosine of pi over 6, which is square root of 3 over 2, sine of pi over 6, which is 1/2. Then cosine of pi over 3 is 1/2. Sine pi over 3 is square root of 3 over 2. So I'm getting decimal approximations here. Then quadrantal angles. Well, straight up, cosine is 0, sine is 1. And then I have my 2 pi over 3, 5 pi over 6. Then pi, cosine is straight left, and sine is 0. Then I continue on into the third quadrant, into the straight down. Cosine is 0, sine is -1, and then continue on to the fourth quadrant. So notice the progression of my points then. I start right here at 3, 0, at t equals 0, and I go up to the left, back down, down to the right, and then back up to the finish. Now, if I go t equals 2 pi, I would be back here. And then t equals 5 pi over 2 would go back up to here. So basically, this is an ellipse that travels from the positive x-axis around back to the beginning again. Okay. So key thing here is just simply knowing your sine and cosine values of the special angles. I wonder if I ever told you guys to learn that. I think I did.
That's the smartest thing I've ever heard anyone say about anything.
Okay. All right, now, writing parametric equations in rectangular form. Okay, so we have parametric equations, x equals t squared minus 1 and y equals 2t plus 3. What we're trying to do is get y as a function of x instead of x as a function of t, y as a function of t. So how do we do that? Well, what we do is we solve for t in terms of y and then plug that in to x. So notice what I did. I took my y equals 2t plus 3, and I got t alone. Okay, so I subtract 3, so I have y minus 3 equals 2t, divide by 2, and I have t equals y minus 3 over 2. Now, still the wrong button. That's annoying. Hold on. Okay, so we took our t in terms of y, and then we go to our x equation, and we have x equals t squared minus 1. So here's t squared minus 1. Now notice what we ended up with is x is a function of y, which is a rectangular equation. Now, the other way we could do this is we could solve for t in terms of x and then plug that into y. So if I solve for t in terms of x, I add 1 to both sides, and so I have t squared equals x plus 1. I take square root of both sides, and I have t equals plus or minus square root of x plus 1. Now I plug that into the y equation, so y equals 2t, or 2 times plus or minus square root of x plus 1, plus 3. So notice I have y is a function of x, which is a rectangular equation. Now our choice was either have x alone and then have no plus or minus, so this is going to be a parabola facing to the right, or we have y alone, which we're more comfortable with, but then that gives us a plus or minus. This is basically two equations in one. So it is pretty simple algebra though. Now if x is a function of cosine t and y is a function of sine t, then we can use the Pythagorean identity that sine squared theta plus cosine squared theta equals 1, which sounds complicated. It really is pretty simple. So let's take an example here. If x is 5 cosine t and y is 3 sine t, then what we do is we get cosine t and sine t alone. So that means divide both sides by 5, cosine t is x over 5. Divide both sides by 3 here, and sine t is y over 3. So we have now cosine squared plus sine squared equals 1. Well, square the x over 5, I've got cosine squared. Square the y over 3, I've got sine squared. So cosine squared plus sine squared equals 1. Look what just happened here. We now have an equation with just x's and y's and no t's. So we've just translated parametric into rectangular. And we could clean it up, just square both sides here, so x squared over 25 plus y squared over 9 equals 1, and I know that's going to be an ellipse also. Okay, now, we're going to crank up the juice just a bit. Okay. Instead of our angle just being t, we're going to make our angle 3t. So I have x is 2 cosine 3t plus 1, and y is 4 sine 3t minus 7. Now remember, the key here is to get cosine alone. So I subtract 1 from both sides, I have x minus 1, divide by 2, x minus 1 over 2, that's cosine of 3t. And I'm going to do the same thing over here. I add 7 to both sides, and then I divide by 4. So I have cosine 3t, sine 3t. Okay, now, sine squared plus cosine squared equals 1, no matter what the angle is. So if the angle is t, that's fine. If the angle is 3t, that's also fine. So notice I don't have to divide by 3 or anything to get rid of that 3. I just say sine squared of any angle plus cosine squared of that same angle equals 1, and that angle in this case happens to be 3t. So now all I do is say cosine squared, x minus 1 over 2 squared, plus sine squared, y plus 7 over 4 squared, equals 1. And once again, if I want to clean it up, x minus 1 quantity squared over 2 squared plus y plus 7 quantity squared over 4 squared equals 1. And once again, I know that's going to be an ellipse. So the main thing I wanted to demonstrate here is this Pythagorean identity works whether your angle is t or 3t or 8t or whatever, as long as it's the same in both. Now it won't work if one of them was 3t and the other was 5t. That wouldn't work. But if they're the same value in terms of t, then you can use the Pythagorean identity here. Okay, last one. We're going to write rectangular equations in parametric form. Okay, so basically what that means, we start with y as a function of x, and we turn it into x as a function of t and y as a function of t. So the first one is y equals 5x plus 2. Now, the simple thing to do is let x equal t. So now x is a function of t. X equals t. Well, if x equals t, then all I have to do is substitute t in for x, and I have y equals 5t plus 2. So notice what I have. X is a function of t, y is a function of t.
Easy.
Okay, now, here's a little bit more juice. We're going x plus 2 squared over 16 plus y minus 4 squared over 25 equals 1. Now, if I say let's let x equal t, now I have to solve for y in terms of t, and that is going to be ugly. Now, students every year make that attempt. Most of them die trying. So you don't want to be one of those people that is afraid of the Pythagorean theorem and tries to do this method. See, this method works when it's linear. It doesn't work as well when it's not linear. So here's what you should do instead. Sine squared plus cosine squared equals 1. What we're going to try to do is make this first thing just one chunk squared. Make this second thing a single chunk squared, and then make the first chunk sine or cosine and the second chunk cosine. So, now here we have x plus 2 cosine squared over 16. We're going to make this x plus 2 over 4 all squared. And the y minus 4 squared over 25 becomes y minus 4 over 5 all squared. So now I have the first chunk. We're going to say let x plus 2 over 4 equal cosine t. And we're going to let y minus 4 over 5 equal sine t, because I know that cosine squared plus sine squared equals 1. Now, could I let y minus 4 over 5 equal cosine t? Yes, I could. The only problem with that is we're really used to having x and cosine related and y and sine related. So we like to keep that relationship going. So notice then I've got, if x plus 2 over 4 equals cosine t, I want to get x alone. So I multiply by 4 and I subtract 2, and x equals 4 cosine t minus 2. So notice x is a function of t. And then multiply by 5, add 4, y equals 5 sine t plus 4. So y is a function of t. That's it. I just went from a rectangular equation to a parametric, I should say a pair of parametric equations. So, piece of cake. Have fun with these.